We are reviewing 1.1a, so let's review. Now, as important is about a mole. As you know, in chemistry, we cannot count the particles. If I ask you to get two molecules of water, you cannot get a two molecules of water. If I say get a two atoms of sodium, you cannot get two atoms of sodium because the particles are too small to be seen with your eyes. So you cannot count them directly in the laboratory. So instead we measure the mass. All right. So we use mole. So mole is something that relates the mass of the substance to the number of particles. So we'll jump into the mole in a moment. So you can see here the number of particles are different in both cases, but the mass is same. Over here the particles are same, but the mass is different. All right. So how we work in chemistry, we use a mole. One mole of any substance is equal to Avogadro's number of particles. So Avogadro's number is given by this symbol. So all of you know Avogadro's number means 0.6.022 into 10 raised by 23 particles. So one mole contains these many particles. Now particles can be of various types. So particles can be atoms. For example, you have sodium, iron, helium. When you just have atoms, it can be molecules. For a molecules, you can have HCl, CO2, you can O2 have O2. They can be ions. For ions, you can have Na plus, Cl minus, O2 minus. And here you can do one more addition, that is formula units. Formula units. For formula units, you can have ionic compounds like NaCl, MgO. So uh, this is the mole, the particle could be, so all these things, atoms, molecules, ions, or formula units. And we just discussed that one mole of any substance will contain Avogadro's number of particles. So this things makes calculations very easier. Then you have atomic mass and molar mass. Atomic mass is measured in AMU. AMU, atomic mass unit. For AMU, you need to have a periodic table. Suppose we have got a lithium here. In a lithium, you see this small number and you see the bigger number. The small number is called the atomic number. On the other hand, the bigger number is called a mass number, or you can call it as a atomic mass. Whatever you want to name it, you can say it. And atomic mass is measured in AMU. AMU stands for atomic mass unit. Atomic mass unit. Then you have mass of 1 mole. Mass of 1 mole is said to be a molar mass. That's said to be a molar mass. So the molar mass is the mass of 1 mole of substance in grams. Clear? And numerically, these values are equal to each other. Suppose if I have got a magnesium, the magnesium has mass of one atom as 24.30 AMU. And if I say mass of 1 mole of Mg, that's equal to 24.30, but now this time the unit is gram per mole. So you can see that they are numerically equal to each other. Then you can convert moles to mass, mass to moles. So interconversions are very easy. For that you need to use a formula where M stands for mass. So mass is always measured in grams. N is moles, which is given as MOL, and this is molar mass. So I hope you all remember molar mass is sum of masses of all atoms in a compound. We'll take it, we'll do the calculation so it will be more clear. And you can also use Avogadro's number to convert between moles and particles. All right, so you can have this relationship: the moles is equal to number of particles over Avogadro's number. So this is the another formula. Now let's see some calculations so that we have a secure understanding of this concept. They are asking how many moles, so you are calculating the moles present in 44 gram of CO2. So gram is a unit of mass. So you have got moles and you have mass. So the formula which you're gonna use is so I have written it here as well. I have kept it easy so that you know how to apply it. So you have to calculate moles and they have given you mass. This is the formula. So mass is equal to moles into molar mass. So mass is 44 grams. Moles we have to calculate, and molar mass. How do we calculate the molar mass? So for CO2 we have to calculate molar mass. Over here you have carbon. You have to consider the mass of carbon, which is 12.01, and oxygen as 16. So plug in the value. So you have 1 times carbon plus 2 times oxygen. So 1 times 12.01 plus 2 times 16. So you're gonna solve it. 32. So you get it at 44.01 grams per mole, because this is a mass of 1 mole. Plug in the value of molar mass. So you get your answer as 0.99. So you have two significant figures. So you can say here 1.0 grams. All right. How many molecules are present in 0.50 mole of NH3? You have to calculate number of molecules. So number of molecules means number of particles has to be calculated. You are provided with 0.50 moles of NH3. So we have chosen a formula. Number of moles is equal to number of particles over Avogadro's number. Correctly plug in the value. 0.50 is equal to number of particles we don't know, which is molecules, and Avogadro's number is 6.022 into 10 raised power 23. I would suggest you to see the formula sheet, what is the value of Avogadro's number given to you, and use the same. So solving it so you get your answer as 3.011 into 10 raised power 23. So 2 sig figs, so you will have 3.0 into 10 raised power 23 molecules. This is how you're gonna solve. Is this clear? Next question, I want you to pause the video and try to do the question by yourself. Let's check your answers. A sample contains 3.01 into 10 raised power 23 molecules. So you have these many molecules. How many moles are present? So hopefully you have predicted the right formula. So here is the formula. So moles is equal to number of molecules over Avogadro's number. Plugging in the value, so 3.01 into 10 raised power 23 divided by 6.022 into 10 raised power 23. So you get your answer as 0.499. So you have this is the answer. So 0.500 is the number of moles this present in this sample. Next question, which of the following numerical expression? So they are asking you about of course it's not following, so it's what is the numerical expression that gives number of moles in 36 grams of water. So this is mass, the number of moles, you are calculating the moles. So formula is number of moles is equal to mass over molar mass. It's the same formula. The formula was moles, mass is equal to moles into molar mass. All right. So here you go. Number of moles. So you're finding number of moles. The mass is 36 and the molar mass of water. So you can have 1 times hydrogen. So you know the mass of hydrogen is 1. Sorry, it's 2 times hydrogen plus oxygen is 1 time. So oxygen is 16. So your expression should look like this. And the unit's gonna be MOL, mole. Next comes a sample of which of the following compound has the greatest mass if each sample contains 1 mole. They are asking you about the greatest mass and all of them has 1 mole. So we will simply find the mass. How we will find the mass? Technically we are finding the molar mass. All of you can see carbon, 1 times carbon plus 2 times oxygen. Plug in the value of carbon. Carbon is 12. You can look here. Plus 2 times oxygen. Oxygen is 16. So it comes out to be 44 grams per mole. Similarly, 2 times hydrogen plus 1 times oxygen. So 2 times 1 plus 1 times 16. So it comes out to be 18 grams per mole. Similarly, for carbon, 1 times carbon plus 4 times hydrogen, 1 times 12 plus 4 times 1, so it's 4 actually. So it comes 16 grams per mole. Similarly, sulfur, so sulfur is 32, oxygen is 16 times 2, so it comes out to be 64 grams per mole. So which of them has a greatest mass? It's all about reading the question correctly so that you can answer the question. I would suggest you to think properly to jump for the answer. So here you go. So answer gonna be D. Next question. In a laboratory experiment, a student is provided with a solid sample of pure iron. The student aims to calculate the total number of atoms in the sample. So you have to find the total number of atoms in the sample. Assume the laboratory conditions are 1 atmospheric and 298 Kelvin. Which of the following pieces of information would be most useful to determine the number of atoms? So you have to find number of atoms. So for number of atoms, so you saw the formula. I'll just take you to the formula. You have to count the number of atoms. So number of particles, for that you need to have a moles and a Avogadro's number. And how can you find the moles? You can use this formula to calculate the moles. So I want you to see this question now. So the mass of the sample, okay, so you saw number of moles is equal to mass over molar mass, and you also know 1 mole is equal to Avogadro's number of particles. So okay, we need to know the mass, we don't need to know the color, we don't need to know the density, we don't need to know the melting point. So answer gonna be A. So this is how you'll solve this question. Now I want you to solve more question and develop a secure understanding.